Least squares approximation. Least squares approximation, also known as regression, is a technique used whenever number of observations is greater than number of unknowns. The least square solution is given by this expression lambda hat 5p phi transpose inverse, or the inverse of the Grams matrix, multiplying phi pl. Let me just make an analogy here, okay, a comparison. Least squares approximation, lambda hat equals to phi p phi transpose inverse phi p l. Does it remind you of something? Well, it should, because it is very similar to the least squares parametric adjustment. Actually, the linear least squares parametric adjustment, which is a transpose PA inverse a transpose PL. So the similarities is obvious in terms of the structure. What we have also is we can make a comparison. We have design matrix in the least squares parametric adjustment. We have the van der Monde matrix in the least squares approximation. The covariance matrix of the parameters in the least squares parametric adjustment is a transpose PA inverse, so which is an inverse. The covariance matrix of the coefficients, the estimated coefficients, is phi transpose p phi inverse, which is g minus 1. By analogy with the parametric adjustment, other elements can be defined. We can compute, of course, the residuals, can compute the covariance matrix of the residuals, etc., etc. We can compute the a-posteriori variance factor. If necessary, we can rescale the covariance matrices, estimated covariance matrices. The statistical tests can be performed the same way as in the adjustment, the chi-square goodness of fit test, test on the a-posteriori variance factor, test on residual outliers. Now, interpolation, let me here present a definition that is, it should broaden your understanding about interpolation. Interpolation is a process of determining, so let's suppose we have these sample points here. Interpolation, the process of determining the value of a function between 2 points at which it has prescribed values. So here if we have basically a function connecting 2 points, yeah, indeed, we can determine values between them. A similar process using more than 2 points at which the function has prescribed values. Function has prescribed values means that the observations are part of the function. Okay, in other words, the function has to cross the observations. Okay, so this is now a second definition, which is broader. Okay, it broadens your understanding, because you would think of interpolation as determine values of points between two known values. Here we are talking about defining a function that contains the observations. The process of approximating a given function by using its values at a discrete set of points. Okay, values at discrete set of points. They have to cross here. It is very important because the approximation would be if you have the sample points, okay, and the function will not, it may, but will basically not touch the sample points. So we have the observations, we have the estimate value, and we're going to have a difference that is the residual. We define residual as t hat minus L. What about interpolation? Well, in these points here, t hat equals to L. Therefore, residual equals to 0. So this is a characteristic of interpolation. Residuals are equal to 0. We can say that the fit is perfect. Here we go. Least square interpolation is a technique used whenever number of observations equals the number of unknowns. In this case, in the case of least square interpolation, residuals are equal to 0. In the problem interpolation, the fit is perfect because residuals equals to 0 and t hat equals to L. Okay? Fit is perfect, residuals are always 0. Well, since the van der Monde matrix is square and regular, therefore its transpose is also square and regular, we can obtain the solution for the coefficients directly from the polynomial representation. So this is t equals to phi transpose lambda. This is the deterministic expression for the trend that's equal to observations. We can use now this term to obtain the value of lambdas. Lambda equals to phi transpose inverse multiplying L. We can obtain the same equation if you look at the equation from the least squares approximation, which is given here. But because phi, the van der Monde matrix, is square and regular, we can apply matrix property. The inverse of the product of 5p phi transpose equals to inverting and reversing the order of these elements. So it's going to be phi transpose inverse, p inverse, phi inverse, multiplying phi pl. So what we have here is phi inverse cancels out phi, p inverse cancels out p, and here is the expression to get the least square solution for interpolation. Please note then that there are no weight matrix. No weight matrix. All points, all observations have the same weight. Because there is no weight matrix, we cannot do any quality control.